everyone, and welcome to the last lesson of Activity 30, Lesson 30.3, which starts on page 441 in your Springboard books, and you will definitely need a pencil and a calculator today. Now, to start this lesson, we are going to talk about finding the area of a rhombus. Now, remember, a rhombus is officially a parallelogram. So to find the area of a rhombus, one of the formulas we can possibly use is just base times height, because remember, a rhombus is a parallelogram. Now in this particular problem, however, we are not given the height. We are given the bases on the sides all around are 5 feet, but we don't know the height. Now, something we can figure out is if we draw in the other diagonal, AC. The diagonals in a rhombus are the perpendicular bisectors of each other. So these pieces would be congruent and these pieces would be congruent. So if BD was 6, each of these pieces would be 3. And because of that perpendicular bisector nature and that right angle, what we could do here to figure out this missing piece here, we could use Pythagorean theorem, because right now what's happening is we have this right triangle, AB, we'll call this X, this intersection here, and this is 5, this is 3, and if we're searching for this piece here, we can use Pythagorean theorem to find this piece, which 5 squared equals x squared plus 3 squared, 25 minus 9 is 16, so our missing piece is 4. Now, again, both of those pieces are 4 for a total diagonal length from A to C of 8. Oops, which goes down actually officially here. Now, beyond that, what ends up happening is if we wanted to figure out the overall area using these triangles, officially what's going on here is we have 4 congruent right triangles, right? Each of these are 3, each of these are 4. So it's basically saying 4 of these areas of the triangle equal our area of our rhombus. So 4 times 1/2 base times height, and then those right triangles, our base and our height are 3 and 4, the lengths of the legs, right? Like we see here, again, 3 and 4. So what's happening is we end up getting 4 times 1/2 of 12, which ends up being 24 square feet. Now, if we were going to derive a formula, again, we had that the area of our rhombus, in this case, was the area of 4 of those right triangles put together. So 1/2 base times height. Well, the base and the height were half of diagonal 1, diagonal BD, and the height was diagonal 2. So if we put this all together, 4 times 1/2 times 1/2 of diagonal 1 times 1/2 of diagonal 2, well, 4 times 1/2 times 1/2 times 1/2 ends up becoming 4 times 1/8, which is really just 1/2. You multiply 4 times 1/2 times 1/2 times 1/2, you end up just getting 1/2 diagonal 1 times diagonal 2. So you will see sometimes this formula used also for the area of a rhombus. Okay, so we have basically 2 formulas for that. Now to actually use that, we'll work with some examples later on. Now on the next page, we have a trapezoid. Okay, and notice the trapezoid has the height, which is again perpendicular to the base, and we have 2 different bases here, base 1 and base 2. And notice there's 2 different triangles here. This triangle's area would be found by taking 1/2 base 1 times base 1, I'll put it down here, times the height, right? Base times height, again, where that's perpendicular. And then the other triangle also would be found its area by taking 1/2 the base, this time a different size base, and then again that perpendicular height, which is actually the same height as our first triangle, right? height here where it's perpendicular. Well, again, the total then, area of our trapezoid, would be both of these added together. So 1/2 base 1 times the height plus the second triangle's area, base 2 times the height, and then 1/2. Well, notice both of these have in common 1/2 in H and 1/2 in H. So you can factor that out, and you're just left inside with base 1 plus base 2. This is the area of our trapezoid, 1/2 the height, and then times the sum of the bases, the two bases added together. Okay, so if we're going to add to our organizer, we've had the area of a rectangle on the parallelogram. We also had the areas for our triangles, right? We've talked about these over the past few days. Now we're going to add on our last couple of formulas. This next one is going to be the area of a rhombus, which we know the area of a rhombus has two formulas. Officially, it could be 1/2 base times height, because remember, a rhombus is officially a parallelogram. Its base just also happens to be the same all the way around. And then, of course, the height again is where it's perpendicular. Or we can do 1/2 diagonal 1 times diagonal 2. So we would have our picture like this. We would have diagonal 1 and then the length of diagonal 2. So two formulas there. And we also are going to have a formula for the area of a trapezoid. There's only one formula this time to remember. Area of a trapezoid is equal to 1/2 the height, and then the sum of the bases, base 1 plus base 2. So again, here's our trapezoid. Height is where it's perpendicular, and then base 1 and base 2. Doesn't matter which one you call base 1 or base 2. Make sure you get these written down. Now some more examples, dealing back on page 442. We have an examples down here in 4 and 5 with our trapezoids. So a reminder, we have base 1 and we have base 2. Now notice on this one, as we start plugging into the formula, 1/2 the height here is 4. And when we start plugging in, we have base 1 is 2. We just don't have the second base. Okay, so what we need to notice here is if we drop in these perpendicular segments, we have, this is 2, and we could figure out that this base here is 3. Excuse me, I wrote that in a little prematurely, because again, we have a right triangle. And notice the height is going to be the same both here and here. So whatever this comes out to be, they would be the same. And again, it goes back to what we talked about earlier using Pythagorean theorem. X squared. So 25 minus 16 is 9. So this piece here is going to be 3 when we square root. So this is 3 and this is 3. So together, 3 plus 2 plus 3 is a total of 8. So half of 4 is 2, and then 2 plus 8 is 10, for a total of 20 square feet. And then we also have another example here for part B. This time they gave us our two bases, base 1 and base 2. The problem is, as we start plugging this in, we don't have the height. We have base 1 and we have base 2. Now the height this time is going to be found by looking at the fact that this is a 45, 45, 90. Now if this is 4, this is 4, this would be 5. So we have a 45, 45, 90 right triangle. If this leg is 5, so is the other side across from the 45. So this would also have to be 5. So half of 5 is 2.5 times 13. So 2.5 times 13 is 32.5 square feet. Now we're going to skip over the question number 5, and we're going to look at the last two examples here for 6 and 7. We have a couple more trapezoid problems. Again, we have another one dealing with the 45-45 here, because again, we have our bases, but we don't have our height. So as we start plugging in the area of the trapezoid, 1/2 the height, base 1 plus base 2. Again, the height here, if this is 12, this is 12. And then these other two pieces would be the same, and they have to add up for a total space of 20. So each one would have to be 4 and 4. And again, this height here would also be 4, since this is a 45-45 90. So half of 4 is 2. 12 plus 20 is 32. 2 times 32 is 64 square inches. Last example for the day. This one's a little bit different because we only have one of our two bases. So as we start plugging this in, we don't have the height, and we only have one base is 26 to start. Now, this is a 30, 60, 90, and notice the side across from the 90 is the 14, so which means the side across from the 30 is half of that, so 7. Now, if we draw this in on the other side, because notice it's isosceles, this would also have to be 7. And if together everything is 26, this middle piece here would have to be 12, because 7 plus 12 plus 7 is that total base length of 26, which means this base here would also have to be 12. All right, last but not least, the height is found by looking at the fact that this is the side across from the 60. And we would have to take the side across from the 30 and multiply it by the square root of 3 to get our height, which is just 7 square root 3. Now, when we approximate this, 1/2 of 7 times the square root of 3 times 26 plus 12, which is 38, we get a total of about 230.4. All right, thanks everyone for watching. We will work more with the area of our trapezoids and our rhombuses in class.